Saturn's rings already falling into the planet. Bright bands of ice circle the planet in perfect silence, glowing against black space like something permanent. Then, the camera drops beneath them and the illusion breaks. Tiny streams of ice are falling downward into Saturn's atmosphere right now, slipping out of orbit and vanishing into the clouds below. It looks stable, it is not. Cassini flew through the system and detected charged debris pouring off the rings fast enough to fill an Olympic swimming pool every 30 minutes. Faint streaks appear inside the atmosphere beneath the rings themselves. The planet is eating its own orbit. If the rings are stable, they should remain suspended around Saturn, but material is already raining into the planet. For decades, scientists believed the loss was slow enough to barely matter. Then, the measurements arrived. The collapse was massively underestimated. Ice particles raining into Saturn's clouds. From a distance, the system still looks untouched. Huge bright circles wrapped around a gas giant nearly 1 billion miles away. But inside the orbit, gravity and magnetic forces are dragging the structure downward piece by piece, turning motion into destruction. And the pressure changes immediately. Because this may not be a permanent feature of the solar system at all, human civilization could exist during the final era of Saturn's rings, watching the most iconic structure in the sky slowly erase itself in real time. The system still shines. The collapse is already happening. Saturn's rings feeding material into the atmosphere. Beneath the bright orbit, the planet's upper clouds begin to glow with thin, dark streaks that should not exist there. Charged ice particles peel away from the rings, follow invisible magnetic paths downward, and disappear into the atmosphere below, while enormous ring shadows slide across the cloud tops overhead. Dark atmospheric streaks directly beneath the rings. At first, it still feels contained, a slow leak, a few particles falling out of place. Then the scale changes. Some regions are losing over 20,000 pounds of material every second, enough frozen debris to bury entire buildings if it happened on Earth. And the source of the damage is no longer separate from the target. If Saturn's gravity stabilizes the rings, orbiting should remain balanced. But the gravity is helping destroy them. The planet itself becomes part of the collapse mechanism. Every orbit feeds more debris downward. Every particle that falls changes the balance slightly, allowing more material to drift loose on the next pass. What looked like stable motion now behaves like a recycling loop that continuously turns structure into loss. The system is helping itself fail. Far above the clouds, the rings still appear calm and perfectly shaped. But below them, entire atmospheric bands darken where the debris keeps falling, connecting the orbit directly to the planet in a way scientists never expected to see this clearly. Saturn's rings are no longer just circling the planet. They are feeding it. Cassini crossing beneath Saturn's rings. The spacecraft slips through the narrow gap between the planet and the inner edge of the rings, while tiny ice grains strike its instruments fast enough to register like sudden bursts of static. Outside the windows, bright orbiting bands still appear smooth and stable. Inside the data streams, something else is happening. Cassini flying through the narrow ring gap. Magnetic readings flood the monitoring screens as scientists begin mapping the movement of particles drifting inward toward Saturn. The explanation seems simple at first. Tiny fragments break loose, spiral slowly downward, and disappear into the atmosphere over enormous stretches of time. That makes sense. For a moment. If tiny particles drift inward slowly, the ring should survive for ages. But the measured loss is far too large. The numbers refuse to settle into the old timeline. Scientists once believed the rings could survive for more than 100 million years. Cassini's direct measurements suddenly make that confidence harder to defend, because the observed material loss is happening faster than the accepted models can comfortably explain. The slow decay explanation no longer matches the data. And that changes more than Saturn. Because planetary systems are supposed to behave predictably once gravity settles them into orbit. If the calculations work, but the real measurements keep disagreeing, then the problem may not be a small error inside the rings. The problem may be that the system itself behaves differently than human models expected once direct observation finally becomes possible. The orbit still looks calm. The timeline underneath it is beginning to collapse. Saturn's rings thinning faster than predicted. Cassini records enormous particle flow rates pouring out of the rings, while scientists compare the new measurements against decades of older models that once described the system as ancient and stable. On screen, density maps begin showing regions where material is no longer where it should be. Ring density maps visibly thinning over time. The change is subtle at first, faint gaps, slightly weaker bands. Then the comparisons continue and the pattern refuses to disappear. Saturn keeps orbiting peacefully, the rings still glowing across space exactly the way people expect them to look, while the structure underneath them steadily loses mass. The system looks permanent, the numbers do not. If the rings are ancient stable structures, decay should remain slow, but the system is emptying itself rapidly. That contradiction breaks the explanation apart almost instantly. The old models only worked because the loss process was assumed to be gentle enough to barely matter across cosmic time. Cassini's measurements replace that timeline with something far shorter and far more fragile. The rings may not survive long on cosmic timescales. Some estimates now suggest major loss could happen within 100 million years, which sounds enormous until compared to the age of the solar system itself. A structure once treated like a permanent feature may actually exist for only a brief fraction of planetary history. And the danger changes again. Because now the problem is not just disappearing ice. The problem is that visible stability can no longer be trusted. Saturn still looks calm, balanced, untouched. Meanwhile, the orbit keeps draining itself in plain sight. Saturn orbiting beside its temporary rings. The planet keeps turning beneath pale bands of ice, while frozen debris continues falling into the glowing clouds below. And across long stretches of time, the rings slowly lose brightness as more material disappears inward instead of spreading harmlessly into space. The motion never stops. The loss never stops either. If temporary debris naturally spreads out, the rings should slowly weaken evenly. But Saturn keeps pulling the destruction inward. That is the final reversal. The rings were never permanent planetary features. What humans treated as part of Saturn itself may only be a temporary arrangement of surviving material caught inside a system already consuming it. The orbit preserves the collapse by continuously concentrating the debris back toward the planet, feeding the atmosphere while the structure above grows thinner generation after generation. And the timeline becomes strangely personal. Dinosaurs lived closer to the formation of the rings than the eventual death of Saturn itself. For most of the planet's existence, these bright circles may not have been there at all. Long after they disappear, Saturn will still continue orbiting the Sun almost unchanged. Saturn alone after the rings vanish. That image changes everything, because it means humanity may exist during an unusually brief visual era of the solar system, watching a planetary feature that future civilizations might never see with their own eyes. The system still works. The beauty was temporary.